I hope you all guys seen this amazing short video, like Adam. If you haven't yet, I really recommend you to go to YouTube after this talk, or not now, okay, after this talk, because it's really hard to show on projector, especially this small, and the video is a bit dark. All my slides are a bit dark, so it probably will be a bit hard to see what's going on. But yeah, I want to show you like a few things about this demo, and our demo team has a plan to release a series of blog posts online. The first one I think already is posted about. The first blog post is about the story, graphics, and the art of the demo. Yeah, it's really long and it's really cool, and expect more. But we in Unity understand that the high quality graphics is what games must have these days. So we want all games made in Unity to look like Adam demo. And we are actively working right now. So, and this was actually not the first real-time short we built. So the first one was, I think, in 2012. It was called Butterfly Demo. We made it with a traditional CG studio called Passion Pictures, and this was the project where we experimented with physically based shading and handling big scenes. So basically, some of the work from this demo went into Unity 5 physically based shading and stuff. So. Also, we like a few years ago created a mobile demo. I probably have seen it. Like all the demos I'm talking about, so they are available on YouTube. So if you're interested, you can go and watch. And with Unity 5, we released a demo called Blacksmith, which is like really cool, and it was our first experience of full in-house production. So, and our latest, I would say, demo is called Adam. So, and we don't have much time, and within the time we have, I'm going to show you a few things about it. So, the first thing is, first one, don't mind that I completely forgot that some of my slides were in Russian. So, yeah, unless you can read a few Russian words, just I don't know, try to translate a bit really quickly. But it's good that I usually don't have much text on my slides, so just pictures, so it should be okay. So the first thing people usually ask us what the team size was, so and like how much time the project took. So the project took like approximately 8 months. So first was 2 months pre-production and 4 months first part and 2 months next part. So we released the first part at GDC, if I'm not mistaken, and the second part at the beginning of June during Unite. So the team was quite small, so only 8 people ever touched Unity. So it basically was 8 people plus producer and like a few freelancers working on models, animations, rigs and stuff. And we also had 2 actors, one theatrical actor and one whatever this guy is called, the one which does tricks in the movies. I forgot the word. Anyone? Stunt. Yeah. Okay. Yeah, this guy. Yeah. And basically, I want to jump to the. Should be fine. So, if you're familiar with Unity, it's basically how the production of the movie looked at the very final steps. So you can see we got here like a sequencer, and the guy can change pretty much in real time, like everything. So you can see that there are a lot of parameters. You can change like weather conditions, like shadows from clouds and stuff. It's well, if you're familiar with Unity, it's kind of okay. You can change stuff in play mode. But when I've been talking to CG artists, like in traditional CG studios which make, like movies and stuff, they were really impressed because it's real time. You don't need to go to some software, change something, and go to your server farm, I don't know, and to render that, and after that go to pre-production. Yeah, so basically everything runs in editor, and there's like this project where you can just go to any part of the movie and change whatever you want, and it gives complete freedom to well, either director in CG or like a creative director in like sort of game production. Yeah, so basically it looked like this. So like a few words about pre-production. So how it all started. Once again, I want to remind you that there's a really good post on our blog which shows more like cool screenshots and pictures. So well, basically it all started like in traditional CG, so with story, like characters development. So the whole process was kind of a hybrid process, because some of the steps in pipeline were taken from traditional CG, and some of the steps were taken from a game development approach. So here we see like a storyboard with like very rough explanation of what will be in the movie. So next, because the team was like I think the team was in like 4 or 5 countries, so the people were extremely remote, and because they used a few freelancers, it was really important to set the style and choose all the references which later will form the style of the characters and environment. So here you can see something which went to Adam, for the poses, clothes. It was very important to make an environment believable, so it was like a fictional movie, but anyway the environment must be believable. So next thing, like concepts, usual movie production, more concepts, like mood boards to figure out lighting style, lighting colors, and general mood of the scenes. Another one, and we have just seen this shot with the guys. So the next thing is previs. So in traditional CG, previs is when you on like rough gray moving boxes and stuff figure out how the scenes will look, so before shooting and stuff. So it was like it would be really stupid not to do it in Unity from the very beginning. So we created like a bunch of placeholder art. So these are screenshots from Maya, and all the art was imported into Unity. So this is already Unity, and you can, if you've seen the movie, you can tell that this is the outside scene. And so we started prototyping with like these blocks and like not moving characters, and the prototypes gradually evolved into the final movie. And this is like the main difference between traditional CG and real-time movies in not only in Unity but in like any engine. So have more, and we have like a couple of recordings of different stages. So the first one is like you can see some shading, and this is what's good about the real-time engine, because it gives you shading, shadows and stuff for free basically. So like this is the first prototype of his birth chamber, I would say. So after that, like we improved on the prototype, added some camera effects, like how camera should be moving, tested some lighting effects and stuff. So next here you can see, here you can see the prototype model. So it's not final yet. You can see that his neck bends like unnaturally, but this model was used, like this prototype model was used to build the actual model, the actual model when we used like in the end. And here's a prototype of actual environment of the birth chamber. So there's also some placeholder art, but a lot of these 3D models went to the final stage. And what's more here you can see like the first prototype of volumetric fog effect, and it's really cool that you can see this effect obviously done by render engineers in such an early stage, because a creative director can take a part in the development of this effect. So he can influence how this effect looks at the early stage. So he doesn't have to wait when the programmers create like this effect, and it doesn't suit him, and so reduces like iteration time and back and forth going to programmers and artist time. So the next thing is production. So a few words about the main character. So here's Adam, actually evolution of Adam from the super early gray box prototype to almost a final model. And you can probably from the movie you saw that Adam is actually actually very complicated. It's a very complex model. So you can see that it has like a metal skeleton, plastic skin, and this rubber plastic clothes. And we spent a lot of time actually figuring out how all these joints would move, because we wanted him to look human, and we didn't want the joints to restrict his movement. So like with these restrictions, it would be like he would look more robotic. So this is even not the final model. You can see like how complex it is. So yeah, this like a few shots of his rig. So we rigged an animated Adam in Max. So there are a lot of procedural movements. You can see. Well, I'm not really good in anatomy in English, especially, but yeah, like a lot of his movements the movements of his parts are driven like procedurally, and from time to time. 3D artists went back and forth from like it was really common when some scene at the end would affect the actual model of the main character. So 3D models had to go back and like add something to it. So it would be automatically added into the like earlier scenes. It was very easy because it's all real time. So another questions we are asked a lot is about eyes. So the eyes actually were animated by hand using the references we shot using this like on-head camera. So you can see like the reference eyes and the animated eyes, and these eyes really added a lot of effect to the character. The character looks extremely alive. So and we used this low-cost motion capture system called Neuron so we used it from the beginning, and with the actor we managed to record a lot of animations, and the quality was surprisingly good, because most of them we actually used at the end. But to actually capture more advanced animations, we used a Viking setup. So here you can see the stuntman performing, working on the, whatever the things are called in English, I forgot once again. Whatever, just, yeah. But you can see there's like walking sticks. So our two characters, I would say they're robots of the first generation or something. They walk on these walking sticks, and we didn't know from the start what they were supposed to do. So in the first iterations, it was just they were just a scaled model of Adam, so just a bit had a like they were just higher than Adam, but used the same animations. So after that, we found this stuntman who had experience using this, and we shot all the animations. But we, unlike all the other animations, which were like motion captured animations, which were more in traditional CG style, we used more a game development approach. So we shot a few poses and a few states, like walking state, standing idle state, like walking down state, and after that we combined all the states into the final animations into a Unity mechanism system, and it worked surprisingly well. From a traditional CG animation standpoint, that's really it has really saved a lot of time. So these animations on Adam's and all robots' screens was made in After Effects, and after that exported into a sprite sheet. So you can see like the more detailed one is for Adam, and the less detailed ones are like a few variants of other robots. So another thing I want to mention is some sorts of dynamic simulations. Like I've got asked a few times, well, mostly by CG people, but there's a misconception that if it's like a real-time engine, so it's being rendered in real time, everything has to be rendered in real time, and it's not true. So in Adam, nothing, I mean, no physical simulation is rendered in real time. Well, other than like a few particle effects. And what's good about the real-time approach is that you can like pre-bake anything you want in whatever tool you are used to, like Max, Maya, Houdini, and after that import into your like real-time scene. So, for example, people usually ask how this like cloth tearing was done, and it was actually done with cloth modifier in Max, and exported in Alembic format, and imported into Unity, and played as is, as like Alembic mesh cache. So you can see how it looked in Max. There was a big problem to actually make it believable, and with this grabbing gesture, so we couldn't make it look good, like when the character grabs his wrapping. So we kind of so we have kind of hidden it beneath a camera movement. You can see that it starts when it's already grabbed, and in Unity it looked like this. So we imported it in Alembic format. So here the guy selects the mesh to import. Yeah, and animation is just played like this, but it looks extremely cool. It's all pre-baked and looks extremely cool. The actual Alembic importer was made for yet another project by our Japanese team, and it's available on GitHub. And if you want to work with it, I don't have a URL here, but you can Google for Unity Alembic importer and see how it works. Another thing we wanted is to simulate all this like physics things like cables and stuff. And we actually wanted to do it in Unity, not to jump back and forth between the various software. And we find this really great plugin called CurrentFX. And with it, we were able to bake as, for example, the cables and some other things. So what it basically does, it using Unity physics, it simulates the behavior of like whatever you want to simulate, and it bakes all the mesh data into like cache files, and after that you can load them and play these cache files. So they tend to one thing is that they tend to be very big, but it works and it looks really cool. So the same thing was used in this scene where like the robot was shot and fractured. So you can see like the robot is like fractured into like a few pieces, and the ground also like fractured when the bullet hit. So like this. So this is all pre-baked using this CurrentFX. Another use case was with clothes. So you can see the orange parts are pre-baked, and everything else is just skinned mesh. Yeah, look like this. Oh shit, another slide in Russian. Well, what the slide was basically saying is crowd simulation. So another really cool task was to create a believable crowd of robots. So when they all move out of the chambers, it was a really hard task because first of all it had to work in Unity. Like second, it had to be deterministic, meaning that when you run the simulation like a few times, it always had to have the same results depending on beginning states of variables and stuff. Well, yeah, and it had to work with our new sequencer. So we ended up building this tool based on vector fields. So we built a tool inside the Unity where you can like paint vector fields, and on these vector fields you can spawn a few variations of robots, which which looked like this. So a few variations of robots were spawned, and you could select any of them, and you could see the path it's taking. You can change it. You could change every variable of the robot movement at any time. So it was completely deterministic, and it allowed artists to have complete control over the behavior of the robots. And we made 4 variants for the behavior. Like if you watch closely, you can see that some of them are like disoriented, and others like just walking forward and stuff. And all these behaviors are controlled with mechanism state machines. So we have like 4 of these state machines for each behavior. Yeah, and like this shows that even if you don't have something built in Unity, you can create it yourself, and you can create a tool. For example, this CurrentFX tool is also created in the editor. So we can do that or either get it from the asset store. And probably the last thing about the demo I want to briefly mention is like some of the tech which made the demo possible. So I would like to split all the items into like 3 groups. The first one is what is already available. The second is what is not built in Unity, but you can get it from asset store and GitHub, like for example that CurrentFX plugin. And the last one is the algorithms we used, like our render engineers implemented, which are not part of Unity, but which we probably will release at some point, but using like whatever published algorithm you can implement it using Unity if you want. So the first thing is, of course, the Unity editor itself, and all the 5.0 features with like physically based rendering and global illumination. So it looks extremely cool. But in 5.4, which is about to be released, like I hope in a week or two, we added a lot of performance optimizations. A lot of these optimizations are related to graphics and VR. And this demo was made in like 5.4 with a few changes. Already now you can go and download 5.4 and check all the new cool stuff. So another thing is cinematic image effects. So for maybe half a year or more, a specialized team within Unity is working on this image effects, because we understand that the image effects is what makes like, good content look great and poor content look good. So we created this Bitbucket repository with the current state of image effects. So there are a few, and you can try them completely free. We made the image effects. Well, we hosted image effects on Bitbucket to be able to release them more frequently, not to tie release dates to like major Unity version, and because the work on Unity moves much slower than we when we would like to. So, so if you haven't yet looked at these image effects, I really recommend it to do and look. So a few of them were used in the demo. So first one is screen space reflections, which you can see in the like this water, whatever are they called in English? Forgetting words. Puddles. Water puddles. Okay, yeah, probably. Yeah. Another one is motion blur, and it really adds a lot of life into the movie, because without motion blur it looks kind of synthetic and well, artificial. Well, the next one is depth of field, which allows you to control the focus of the camera. The last one is temporal anti-aliasing. So there's like new anti-aliasing method which takes into account previous frames. So it lets you get rid of like this specular pixel annoying things and like this you know, usual aliasing artifacts like staircases and stuff. So these are all built in, and the really big team is working right now on those effects. And another group is something which was made specifically for the demo. So the first one is real-time lights. As you can see on the head, on the Adam's head, there's this specular reflection, but it has area. So Unity right now has like a directional light, a point light, and if you use, for example, like point light on a like, specular object, you can get this brown specular, which doesn't look real. So we needed some sort of light which looked real and could cast this speculars onto metal surfaces. This is because lights usually, in the real world, lights usually have area. And also another objective was to have a light source which would add like, a specific mood to the scene, and which would affect the volumetrics in the scene to cast like this cool volumetric shadows. So it works. And actually, one of the teams in Unity called Unity Labs actually developed an algorithm for this. You can see how it works. And right now you can, first of all, they have a blog post about this effect, and you can go to labs.unity.com and I think download this effect and use it in your own games. So basically it's here, as I said, labs.unity.com, and there's like an article in the blog about the algorithm used. This I think the last slide in Russian, but I'll just explain what it says. So basically, this area light shows how simple it is to extend the rendering pipeline in Unity, because it doesn't use any source modifications. It just uses common buffers which are available to anyone. So basically, this area light is like a component with a bunch of settings, and using common buffer, it subscribes to a camera event after lighting for all the cameras which can see this lighting effect, and after that it just renders a shape on top of the whole rendered geometry and uses gbuffer to sample depth and kind of bleed lighting on top. So it's kind of that simple, just a component that just interferes with lighting a bit. No source modifications needed. Another one is tube lights. So we needed another source of light, and this one is quite cheap, and you can read about it like here on the blog. And it's basically like approximation of like many point lights. I will not go into detail, but it's really cheap, and it adds just another light source. And if you watch the demo again, you can see where the tube lights are used. It's volumetric fog, which actually adds like a lot of details, and it makes the scene like more epic. And once again, it was an implementation of another published algorithm which was used in Assassin's Creed. You can go and look for this guy, which from the name looks like Polish. Yeah. Bart Wronski. And basically the test of this effect looked like this. So you see it's like the environment with some sort of dust particles, and it interacts with shadows, and it's the algorithm is actually really simple. And basically, it's like you have a bunch of like voxels, and in a compute shader you can calculate the density and the lighting scattering on the voxels, and after that you just use the calculated data in your game when you render. So this is why, for example, things like this, it's partially covered by the fog, because it's like a bit further away. Yeah, so if you're interested, you can go and read this publication. And the last thing I want to mention is the Adam's mask. So we planned a lot of close-ups. So we wanted to make the mask not simple and I don't know, much more complex. So then it looked like this, and this is a combination of a few effects. So first we render depth of everything which is behind of the mask, and we compress the depth in what? Okay, that's okay. So we compress the depth into 0 to 1 range. So what is closer to the surface, it's not blurred, and you can see the effects here. Like what's further from the surface, it's blurred quite heavily. And after that, the mask like refracts light a bit. So we like render the normals, and so after that add like refraction from like what's behind the mask, and I'm switching frame. You probably can see that there's a bit of refraction in Adam's mask. So just switching the effect on and off. And another thing is like the mask glows a bit, so it's sort of effect like inverted ambient occlusion, where instead of like adding shadow, it just adds light. And this, this is just a general standard shader with like physically based shading and stuff. And after that, like everything combined, and it looks like this. And if we look at this like animated, it looks even more cool. Yeah, you can see that there's a frame under it that it like light goes through the mask and it like refracts it a bit. Yeah, so and as I already started explaining, like we plan to release a series of blog posts about the demo, and probably with some of the blog posts there will be like a few parts released into asset store, like we did with the blacksmith demo. I'm not sure if we ever released the whole thing as a project. I'm not sure about that. But at least parts and the effects will be released for sure. And like for example, one of the effect area lights you already can download from labs.unity.com. And if you have any questions, you can like either ask now or like send me email. But first, I want to like introduce a few of my colleagues, and we will be here till like tomorrow. So if you want to talk about getting a if you want to talk about like buying Unity license and stuff, you can talk to Roman and Elena. And if you want to know how to earn a lot of money with the games, you can talk with Slava. He's from like Unity Ads, and he will like tell you everything he knows. And if you have any like technical questions, or if you want to know when like nested prefabs will be released, you can talk to me. Yeah. Okay. So, all right. If you have any questions, feel free to ask. We still have like some time.
So when will be nested prefabs?
Yeah, it's sometime in the future.
All right.
No. Okay. So I don't know if you have any private question, you can just talk to me outside. Yeah. Thanks for listening.